Hello everybody and welcome to the latest issue of the Wiser newsletter. And this week we're going to be taking a look at the world of robots and the rise of the machines, and particularly the global robotics market, technology, innovation, and to finish this off we're going to take a look at Nike and use them as a case study of how robots are being used in the automated manufacturing process. First off, just a reminder that if you like the video, if you like the audio blog, give us a little heart on the Substack page, or give us a subscribe and click the notifications button on the YouTube channel so that you don't miss the next issue of the Wiser newsletter in both video and audio form. In the 2008 movie called WALL-E, a solitary robot is left to clean up the garbage left on planet Earth. Set in the 29th century, after decades of consumerism, greed and neglect, Earth is uninhabitable, and humankind has evacuated to live in giant colonies in space, which all sounds a bit like a Jeff Bezos vision for the future. However, back here on 21st century Earth, the robotics market is doing a whole lot more than just cleaning up after humankind, and the market is booming. In 2020, the global robotics market was valued at $23.6 billion and is predicted to continue growing at a rate of around 20% a year and hit $74 billion by 2026. And it will come as no surprise that China is the largest market in the world, closely followed by Japan, South Korea, the United States, and Germany. Earlier this month, Korean carmaker Hyundai sealed its acquisition of robotics innovator Boston Dynamics. Hyundai's grand strategy is to create a robotics value chain that spans robot component manufacturing, construction, and automation. Now, whilst the company has been exploring Star Wars-style walking vehicles that rely on robotics, it seems it's just as interested in Boston's robotic warehouse workers, which include box stackers called Handle and Stretch. These are robots that are designed to move boxes around the warehouse floor. Now, Boston Dynamics are most famously known for their robo-dog called Spot, which has been trained to follow humans around. Singapore deployed Spot in a park during the first wave of pandemic restrictions last year to help ensure people were socially distancing. Car maker Ford has experimented with Spot at its Van Dyke transmission plant to capture plant data and measurements to help retool the line. The robot dog walks around the plant to capture data about the manufacturing activity of the workers as Ford builds a new engineering model. After announcing the acquisition of Boston Dynamics, Hyundai released a new video of Spot and other robots that aims to create a softer, friendlier image for the robots working for the good of humanity. Hyundai's friendlier depiction of Spot shows the robotic dog leading a blind man through a park. It shows him bringing medical reports on a table to a doctor, and a humanoid robot dancing with a young girl in a park. It's all about crafting an image of robots to improve humanity rather than the often repeated narrative of robots taking jobs. Now, if we look at the various applications of robots, we can see them across all parts of the economy. So let's look at robots in healthcare. Factors like the aging population and shortages of healthcare workers are driving the demand for assistive technology robots. Companies like KUKA and their subsidiary Swisslog are specializing in robots for both inpatient and outpatient services, like the transport of patients in man-carrying machines and moving medicines and hazardous materials safely. In hospitals, a disinfection robot called UVD robots is used to prevent and reduce the spread of infectious diseases, viruses, bacteria, and other types of harmful organic microorganisms in the environment. And the thing about this is that the robot is safe, it's reliable, and it eliminates human error in this very important cleaning role. Now, in Japan, which has an aging population of around 36 million inhabitants over the age of 65, the country is increasingly looking for robots and artificial intelligence to help caregivers in nursing homes to take care of older people. One example is the Paro therapeutic robot. It looks like a baby seal and is designed to relieve stress and anxiety in patients and to treat diseases like Alzheimer's. Now, robots are also being used in things like retail fulfillment. And with the proliferation of e-commerce, the need for automated warehouses is increasing. And Amazon are at the forefront of robotic tech in the fulfillment center. In 2012, Amazon acquired warehouse robot manufacturer Kiva and now use their drive unit to automate warehouse operations. The Amazon family of robots does not stop there. They have Hercules for lifting heavy loads. They have the Pegasus, which is a new generation of lightweight and nimble Kiva replacements. They have the X-Sort. This is a robot for shipping completed parcels out of the door. And then they have RoboStow, which looks like an enormous robot arm for moving items on and off shelving. Outside of the warehouse, you have the Amazon Drone for small parcel delivery to customers, and the Amazon Scout for automated parcel delivery on the streets. But it's not just Amazon who are into robots big time. For example, DHL use robots from low-cost robotics. Locus reported that using their robots, DHL had seen a near doubling of productivity. Now, when you look at robots in manufacturing, one to watch is BMW. BMW has joined forces with chipmaker NVIDIA to create, in quotes, the world's largest custom manufacturing company. BMW has about 31 factories worldwide, and each factory line can produce up to 10 different cars. There are over 100 options for each car and more than 40 BMW models. In all, there are 2,100 possible ways to configure a new BMW. Now, the BMW NVIDIA dynamic factory environment combines advanced computing, robotics, artificial intelligence, and virtual reality software. Now, robots are also big in the defense space. Robots are being deployed to carry out unsafe, murky, and recurring tasks with constant precision and regular accuracy. As well, they're also doing things that are dangerous, such as bomb disposal, reconnaissance, and firefighting. For example, the MARS, which stands for Modular Advanced Armed Robotic System, is an armed robot that carries anything from non-lethal lasers to tear gas and even a grenade launcher. A robot called Dogo from General Robotics looks like a small toy tank, but it carries an actual pistol and is controlled remotely by the special forces teams that use it. A robot called Sapphire is a firefighting robot designed for US Navy ships. And now it's not all about manufacturing and warfare, because robots are big in the kitchen too. Samsung have developed a robot chef. The device works as an extra pair of hands in the kitchen. When a real-life chef is working on part of a dish, Robot Chef can chop, whisk, pour, or clean up as needed based on skills it learns over time or that it downloads from Samsung's skills base. If you wanted to stir a pot of soup, you can download a stirring skill. Then all the chef needs to do is talk to the robot to issue the commands. The robot chef can autonomously understand the location of objects so that the chef can tell it where to find the spoon and which pot to stir it in. UK startup Karakuri also has ambitious goals to bring robots and AI to the food industry with their robot chef canteen. Meanwhile, London-based Moli Robotics develops robotic kitchens with oven, hob, sink, and 2 dexterous robotic arms that allow it to cook and clean. Now, outside of the home, you find robots on the street. And the world's first autonomous robot to detect potholes with artificial intelligence is coming to the United Kingdom anytime soon. The startup called Robotize 3D has developed the world's first autonomous robot to patrol the streets in search of potholes. In the UK, around 2 million potholes are fixed every year at an estimated cost of $10 billion. Meanwhile, the real-life equivalent to Wall-E is a startup called Recycle-Eye that uses computer vision system with robotics to recover useful materials from your waste. Now finally, let's look at robots as humans. Delta Airlines have partnered with Sarcos Robotics to develop a mobile and dexterous exoskeleton straight out of Iron Man. This robotic suit is designed for employees to wear when they have to do heavy lifting. By bearing the weight of the suit payload, the exoskeleton enables the employee to lift up to 200 pounds repeatedly for up to 8 hours at a time without strain or fatigue. Now, at the other end of the spectrum, Edinburgh-based Touch Lab have developed an electronic skin that instills robots with a human-like sense of touch and feel. Their electronic skin is thinner than human skin and can be wrapped around soft and hard surfaces to sense pressure and location and enable ultra-soft grip by the robots. It is difficult to imagine robots picking delicate berry fruits as well as people, but this is what Dogtooth have done with their intelligent robots for soft fruit picking. They have built soft fruit picking AI-powered harvest robots that identify, pick, harvest, and also grade ripe fruits. Also capable of self-navigation between the crop rows, it is capable of picking at night and at low temperatures, and it utilizes artificial intelligence and computer vision technology for grading and navigation purposes. Now let's take a look at Nike in a case study of how they have used robots in the manufacturing process. While robots are already an established part of the manufacturing process for cars, electronics and semiconductors, they have been much slower to take over production of sneakers and clothes. One of the main reasons is that robots have a hard time handling the wide variety of soft materials used to make complicated products like a pair of sneakers. A Nike shoe can have as many as 40 different materials in its upper alone, all of which need to be precisely stacked and fused together to make the shoe. In garment and shoe manufacturing, no single method has offered an ideal solution. A vacuum may pick up pieces of leather, but it can't deal with mesh. Mechanical pinchers fumble with pieces that have different degrees of flexibility and stickiness. Magnets, while great for handling metal, are useless when it comes to fabric. But this has not deterred Nike, the #1 sports brand. And there are 4 ways in which Nike have adopted robot technology into their global manufacturing operations. Number 1, using Grabit's Stack-It robots. In 2017, Nike partnered with Silicon Valley startup Grabit to increase the speed at which its shoe uppers are produced. Grabit has developed a new technology using electroadhesion, which enables robot grabbers to pick up and work with a multitude of objects and materials. The adoption of robotics in the retail industry has been slow, which is largely because robots typically struggle to handle and mold softer materials. But Grabit's technology seems to have overcome this hurdle, with the company claiming the robots can grasp an egg, soft fabric, or a 50-pound box with equal ease. Rather than mimicking a human gripping motion, the robot is fitted with electrodes, which produce an electric field that can adhere to the majority of surfaces, enabling the grippers to pick up an object. Nike has invested in several of Grabit's $100,000 Stack-It robots, which help to make between 300 and 600 pairs of shoes throughout an 8-hour shift. The robots are expensive, but Nike can now produce its shoe uppers in just 50 seconds. Number 2, Geek Plus Smart Robots. In early 2020, Nike announced the arrival of same-day delivery in Japan thanks to a new partnership with smart logistics solutions provider Geek Plus. The company's goods-to-person robot series serves Nike's distribution center in China, carrying products to warehouse workers to reduce costs and improve warehouse efficiency. Geek Plus claimed that the robots have increased Nike's order pick rate from 100 picks per hour to over 300. Number 3, Flyknit 4D knitting. In 2012, Nike debuted its Flyknit technology, which utilizes high-strength fibers to create lightweight uppers that fit like a sock. As well as being exceptionally light, the material provides breathability and support, and it has a low environmental impact. Today, the production of Nike's Flyknit shoes is highly automated. A CNC knitting machine weaves the shoe's upper into one piece, which can reduce labor costs by 50% and material usage by 20%. And finally, we have 3D printing. Nike was a very early adopter of 3D printing. The technology has driven innovation and product customization, and it enabled the brands to produce components that would have been impossible to manufacture using traditional methods. In 2013, Nike Football unveiled the Vapor Laser Talon, its first shoe fitted with a 3D printed plate, which was designed to provide optimal traction on football turf. More recently, the company has leveraged computational design, which allows manufacturers to feed parameters and physical properties into a model to create designs that would be close to impossible for a human to produce. Nike used this technology to produce its Vaporfly Elite Flyprint shoe. In 2018, Nike claimed that its 3D printing prototyping process was 16 times faster than any former method of manufacturing. Now, I hope that you've enjoyed this issue of the Wiser newsletter, which has all been about robots and the use of robots in society and in the economy. If you're watching this video for the first time on the YouTube channel, head over to my Substack page and sign up for the newsletter, because that's where you hear this first. Please do leave me a comment in the comment section below or on the Substack page. And as always, hit the heart button if you like this, hit the like button if you're watching it on YouTube, and I'll see you next week. And in the meantime, remember, insight and information gives you leverage. Thanks for watching. Thanks for listening.